Imagine you're at a birthday party in the year 2100. The cake comes out, candles everywhere, and the number on top doesn't say 80 or 90, it says 150. Everyone laughs like it's impossible, but then you pause because you've heard the rumors. The first 150-year-old might already be alive. So here's the real question. Is living to 150 something humans will actually do? Or is it just a futuristic fantasy that sounds good in headlines? To make this simple, we need to understand one idea. There's a difference between living longer on average and the absolute longest a human body can last. Living longer on average is what happens when we fix the big killers: clean water, vaccines, better heart treatment, safer childbirth, better emergency care. That's why many countries moved from most people die young to many people reach old age. But the absolute longest lifespan is different. It's like asking, even if you do everything right, how long can the human body keep going before it breaks down? Right now, the longest verified human lifespan ever recorded is 122 years. A woman named Jeanne Calment reached 122 years and 164 days, and no one has clearly beaten that record. That matters because if 150 was easy for human biology, we would expect to see at least a few people getting close by now. So why is 150 such a big jump? Because after a certain age, the problem isn't one disease, it's the body's repair system slowly losing power. Here's the simplest way to picture aging. Every day, your body gets tiny damage. You don't feel it, but it happens. Your body also has repair teams that fix most of it. When you're young, the repair teams are fast and strong. When you get older, the repair teams get slower. More damage stays behind. That leftover damage slowly becomes problems we recognize: weaker muscles, slower brain, stiffer blood vessels, higher inflammation, and diseases like heart disease, diabetes, and cancer. So the real question is not, can doctors keep saving you from problems? It's, can we keep the repair teams strong for much longer? That's why scientists say living to 150 would probably require something bigger than normal medicine. It would mean slowing the aging process itself. You might hear big words like DNA damage, cellular cleanup, and inflammation. Let's translate them into plain language. DNA damage is like small typos in your body's instruction manual. Your cells copy this manual again and again. Over time, more typos happen. Most are harmless, some cause trouble. Cellular cleanup is like taking out the trash. Your cells create waste. When you're young, your cells clean it up well. As you age, trash builds up and the system becomes messy. Inflammation is like the body's alarm system. It's helpful when you're injured or sick, but with age, the alarm can stay slightly on all the time. That constant low-level alarm slowly damages tissues. Now, one huge reason people don't live to 150 today is that after 80, 90, 100, the body becomes less stable. Small stresses hit harder. A fall can change everything. A simple infection can become dangerous. Healing takes longer. It's like an old phone battery. It still works, but it drains faster and doesn't bounce back the same way. So what would need to change for 150 to become real? There are basically three big walls that stop us. The first wall is heart and blood vessels. Many people don't die because the heart suddenly gives up. They die because the system slowly gets damaged over decades. Arteries stiffen, blood pressure rises, and organs get less oxygen. If we could keep blood vessels younger longer, that alone could add many healthy years. The second wall is cancer. Cancer risk increases with age because cells have had more time to collect those typos. Even if treatments get better, extreme old age means the body has had a long time to build up risks. To reach 150, we would likely need much better prevention, early detection, and better ways to stop cancers from starting in the first place. The third wall is the immune system. The immune system is your security team. When you're young, it catches problems quickly. With age, it gets weaker at fighting real threats and sometimes overreacts in unhelpful ways, causing more inflammation.
This is one reason older people struggle more with infections and recover more slowly. So you might ask, are scientists doing anything about this? Yes, but here's the important part. The real goal of serious researchers is not 150 right away. The first goal is healthy longer. They want to delay the start of age-related diseases. If you can push disease later, people naturally live longer as a side effect. And some researchers think certain medicines might help delay aging-related problems. You might hear names like metformin or rapamycin. Don't think of them as magic pills. Think of them as tools scientists are testing to see if they can slow down parts of the aging process, like calming inflammation, improving the way cells use energy, or improving repair signals. But we should be honest. In humans, we don't yet have a proven drug that clearly extends maximum lifespan. We have promising ideas, animal studies, and early research, but not a clear, this will make humans live to 150. So where does that leave the question? If we keep improving normal healthcare, better surgeries, better heart treatments, better cancer drugs, more people will reach 90, more people will reach 100, and we'll probably see more people live past 110. But 150 is different. It would likely require a new era where we don't just treat diseases after they show up. We slow down the rate at which the body breaks down in the first place. And even if we never reach 150 soon, aiming for it still matters because it pushes medicine towards something better than simply living longer. It pushes us towards aging slower and living healthier.